Good day, class. This is Module 1 of Aerodynamics. So last time we talked about standard sea level conditions constants um, described by the IKO under pressure, density, temperature, and universal gas constant. So pressure, density, temperature, and velocity defines the flow field. So, as you can see on the figure, no, yung flow field is yung field, no, yung surroundings around the airfoil. So, the source of all aerodynamic forces stems from two natural sources. First is the pressure distribution on the surface, no, the normal force acting on the wing or the airfoil. Second is shear stress friction on the surface of the airfoil or the wing. So for the pressure is that when two solid objects interact in a mechanical process, forces are transmitted or applied at the point of contact. But when a solid object interacts with the fluid, things are more difficult to describe because the fluid can change its shapes. For a solid body immersed in a fluid, the point of contact is every point on the surface of the body. The fluid can flow around the body and maintain physical contact at all points. The transmission or application of mechanical forces between a solid body and a fluid occurs at every point on the surface of the body, and the transmission occurs through the fluid pressure. So, what do you mean about the pressure distribution? So, what if you have airfoil, no? And then normal pores acting on the surface of the wing or the airfoil. So, dahil merong normal force, no, state natin like N, no? This is N, and so yung force mo, normal force acting on the airfoil, and then dahil yung airfoil is merong area na tinatamaan, so that is force over area. So nagkakaroon ng pressure distribution dito sa ating airfoil. So yun yung first, no, na source, pressure. Second source naman is shear stress. No, shear stress. So merong streamlines, no, hangin, and then merong rubbing against each other, no, nung fluids and dun sa surface ng ating airfoil. So that is the second source of all aerodynamic forces. So during discussion, madidiscuss natin yung pressure distribution ng upper surface and lower surface, and shear stress nung ating surface or nung ating airfoil. So first, dahil yung air is sinasabi na perfect gas and intermolecular forces are negligible, so the equation of state can be used, no, to solve the properties around of the body, no. Kung ang body mo is ang aircraft, masosolve mo yung properties ng air around or dun sa surroundings ng isang aircraft. So meron tayong sample dito, the air pressure and density at a point on the wing of Boeing 747 or 1.10 times 10 raised to 5 Newton per meter squared and 1.20 kilogram mass per cubic meter respectively. What is the temperature at that point? So solution, sulat muna natin yung given is pressure 1.1 times 10 raised to 5 Newton meter squared. Next is the density, 1.20 kilogram mass per cubic meter. And then, what is the temperature, no? So, unknown ang temperature, ang fluid mo is air. So, with that, no, automatically, ang gagamitin mo equation is equation of state. So, meron kang given na pressure, meron kang given na density, meron kang given na, or unknown na temperature, and the specific gas constant ng air, or universal gas constant ng air. So, for this units, metric, we use R is equal to 287.08 Newton meter per kilogram mass per Kelvin. So, rearranging the equation, P is equal to rho RT, multiplying both sides by 1 over rho R. 1 over rho R. Cancel out. And then T is equal to pressure over rho times the R. No? So, T is equal to 1.10 times 10 raised to 5 Newton meter squared over the density 1.20 kilogram mass per cubic meter times the R 287.08 Newton meter kilogram mass Kelvin. So, temperature is equal to, by numerical, 1.10 times 10 raised to 5, 1.20 times 287.08, and I have 319.3070457. So, ang question, ano yung units, no? So, kung aayusin lang natin yung units, no, dito, lagay natin sa side na to, that is Newton meter squared. Next is kilogram mass, and denominator of denominator, aangat. And then we have Newton meter, and denominator of denominator, this kilogram mass, point Kelvin. So, kilogram mass times Kelvin. So, maka-cancel out. Cancel ang Newton, cancel ang kilogram mass. I have m squared times m, that is cubic meter, and cancel out. So, meron akong units ng Kelvin. So, ganun kadali lang mag-solve ng temperature using the equation of state. Next problem is that the high pressure air storage tank for a supersonic wind tunnel has a volume of 1,000 feet cube if air is stored at pressure of 30 atm and temperature of 530 degrees Rankine. What is the mass of gas stored in the tanks in slugs and in pound mass? So, we have given. So, ang given is volume 1,000 feet cube. If air stored at pressure is 30 atm, temperature of 530 Rankine. So, what is the mass in terms of slugs and pound mass? So, to get the mass, from the equation of state, pressure is equal to rho RT, and density is simply mass over volume. Pwede natin gamitin, yung another feature nung equation of state. So, pressure is equal to mass over volume times RT. So, multiply both sides by volume over RT. So, cancel out. We have mass is equal to PV is over RT. Okay? So, meron kang given na pressure, meron kang given na volume, R for air, air storage tank, and that is in terms of slugs and pound mass, so 1716. Pwede natin gamitin ng 1716 foot-pound force per slug Rankine, or 53.342 foot pound force, pound mass, Rankine, no? It depends kung ano yung hinahanap ng problem. So, for the slugs, so pressure, 30 atm, multiply by 2116.8 pound force per feet squared over 1 atm. And then, volume of 1,000 feet cube over R. So, una, slugs, pwede natin gamitin ang 1716 foot-pound force slug Rankine and temperature of 530 Rankine. So, mass in terms of slugs is so that is 69, no? 69.82451511 and that is a slug. So kung titingnan natin yung dimensional analysis, so cancel out ang ATM, atmospheric pressure, the Rankine. Next naman is, no, kung nalilito kayo, pwede natin tong ayusin with pound force, feet squared, meron kang feet cube over foot, pound force, and slug. No? So, feet cube cancel out and pound force, therefore meron tayong natirang slug. So, correct ang units. So, correct ang mass in terms of slug na 69.824. Next is in terms of pound mass, no? So, kung meron ka ng sagot, so, kung ang mass mo is 69.82451511 slugs, pwede mong gawin is i-convert na lang ito in terms of pound mass. So, 32.174 pound mass, 1 over slug. So, cancel out. M is 2246.533949 pound mass. So, pwede yan, no? Correct yung process. Next naman, no, kung gusto mong ipakita, no, na mass is equal to pressure times volume RT, and yung R na gagamitin mo is the 53.342, pwede din naman. So, 30 atm, 2116.8 PSF, 1 atm. Ang volume is 1,000 feet cube over 53.342 foot-pound force per pound mass Rankine times the 530 temperature. So, we know, no, na makakancel yung mga units and matitira is itong pound mass, no, na pinakita ko naman na kanina. So, let's compare kung malapit or maliit lang ang discrepancy. So, I have 2246.23876 pound mass. So, any process is pwede nating gamitin. Okay? Kopya. Nuggets. Okay? So, pwede tayong next problem, no? So, assume that a point the wing conquered supersonic transport, their temperature is negative 10 degrees Celsius and pressure is 1.7 times 10 raised to 4 Newton meter squared. Calculate the density at this point. So, first is given temperature that is negative 10 degrees Celsius pressure is 1.7 times 10 raised to 4 Newton meter squared. And the unknown is density. Next naman is yung air, no? Kasi point on the wing. So, ang fluid mo dyan is air. So, with the given units, 287.08 Newton meter per kilogram mass Kelvin ang gagamitin natin. So, kailangan natin i-convert ito into absolute units of temperature. So, 273.16 and that is equal to 263. So, negative 10 degrees Celsius, that is 263.16 no, Kelvin. So, density ang hinahanap. We know we can use equation of state. So, multiplying both sides by 1 over RT. And density is equal to pressure over RT. And pressure 1.7 times 10 raised to 4 Newton per meter squared over 287.08 Newton meter kilogram mass Kelvin times 263.16 Kelvin. So, cancel out the units, Newton and denominator, and this is denominator. So, we have m cubed at denominator. This is denominator of denominator. So, aangat. So, ang units is kilogram mass per cubic meter. So, ang numerical or final answer is 0.2250225.833 kilogram mass per cubic meter. Okay. So, tuloy-tuloy lang tayo. Next, at a point in the test section of supersonic wind tunnel, the air pressure and temperature are 0.5 times 10 raised to 5 Newton per meter squared and 240 Kelvin respectively. Calculate the specific volume. So first, no, pwede ka mag-drawing ng supersonic wind tunnel, no? Pero it is not necessary. So dito daw sa test section, no, around this portion, meron kang pressure na equals to 0.5 times 10 raised to 5 Newton meter squared and temperature of 240 Kelvin. So, ang tanong, hinahanap is, ano yung specific volume? So, kailangan nyo na masanay, no, na kailangan iiba nyo yung volume lang, no, yung symbol ng volume lang sa specific volume, and ma-distinguish nyo kung ano yung pinagkaiba ng velocity dun sa volume. Kung sa volume, big or capital V, sa velocity, pwede mong gamitin yung small v. So, sa specific volume, madalas kong ginagamit is with this one, no? Yung may on flick. So, pwede yan. So, specific volume ang hinahanap and specific volume is just a reciprocal of density. So, meron kang pressure, temperature, density. So, ang gagamitin mo equation is equation of state. And dahil nga, no, reciprocal ng density ang specific volume, you can rewrite this one into P is equal to RT over specific volume. So, multiplying both sides by specific volume kasi siya yung hinahanap. And pressure, no, over pressure. Then, specific volume is equal to RT over pressure. So, R and this 4 units, metric 287.08 Newton meter kilogram mass Kelvin times the temperature 240 Kelvin over pressure 0.5 times 10 raised to 5 Newton meter squared. So, kung titingnan natin, no, yung units, kakancel ang Kelvin, kakancel ang Newton. So, meron tayong denominator, kilogram mass, and denominator of denominator aangat, mamumultiply dito sa m, that is cubic meter. So, ayun yung units natin. So, the final answer for specific volume is 287.08 times 240, 0.5 times 10 raised to. So, 1.377984 cubic meter per kilogram mass. Okay? Kopya.